Okay. Um, this video is all about showing you implementing uh, the equations I came up with in a spreadsheet so that you could see that they work. I'm starting off with the first equation, which is the prime number check equation. Really, what I'm starting off is not the whole equation is the prime number check equation, but this part of the equation, the core of the equation, is an equation to tell you how many number of factors there are in any number. So I find out how many factors there are in a given number. I check if the number of factors is 2, and if it's 2, it's a prime number because that's the definition of a prime number. It has two factors, one in itself. So going with that, I'm going to implement this equation, cosine x times pi over n to infinity from n equals 1 to x, blah, 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 right? I'm using the OpenOffice Spreadsheet, and I'm not too familiar with it, so I'm going to implement it the best I can using the functions that I know that spreadsheet has. Okay. Okay. So here's the spreadsheet, right? I created a function called factors, just because the um, the sum this sum function in this spreadsheet seems to be very limited. All it lets you do is just like add columns. It doesn't let you add the output of functions. So I had to implement the sum of the cosines. I had to write a little routine to just pretty much sum the sum of the cosines. I'm gonna show you what it is. Hold on a second. Macro. Okay, so factors, pretty much all it does is sum for 1 equals x, sum from 1 to x, sum the cosines. That's all. I would have done it straight on the spreadsheet, except that the spreadsheet seems to have a very limited sum function. Okay, so that's what factor says. I give it the x value, I give it the power to raise it to, and then I sum the cosines from 1 to x, raising the cosine to that power. Ideally, we want to raise the equation. Ideally says that you want to go to 2 to the infinity, but since 2 to the infinity is really not a number, I just use a very large even number. So if you see here, I sum every number, every column, every column in main, and I raise it to 4,000. 4,000 is a pretty large even number. Okay, so here's the outputs. Here's the graph that it does. This is actually what the equation graphs to for the number of factors. If you see, if for number 1, 1 has 1 factors. For number 2, 2 has 2 factors. For number 3, 3 has 2 factors. 4 has 3 factors. Blah blah blah. You could check it in the internet. Just Google it. They're all perfectly correct. If you keep on going down around 42, you begin to get a little bit of error. The value is supposed to be 8. You get 8.0001. That's because, like I said, the equation ideally wants to go to infinity. I'm raising it to 4,000, which is a pretty high number, but it's not infinity. So after a while, a little bit of error it's going to begin to show. But if I raise this to a higher number, right now I raised it to 4,000. Let me raise it to 8,000. Boom, I get a perfect 8 value. Okay, so the higher even power you raise it to, the more ideal value you get. So if you keep on checking down and down and down and down and down, you see you get the right value, 82664 blah blah blah, with a little bit of error creeping in. But if you raise the power to a higher power, the error will go away. So that's my equation implemented in a spreadsheet. I'm going to put the spreadsheet up on the internet also so people could download it. Right now I did it in OpenOffice. I'm going to see if I do it in Excel and a few other type of spreadsheets so people have options. But that's pretty much the. I mean, my logic has always been solid, but the easiest way to show you that the equation works is to actually test it out in a spreadsheet. Now, this is the number, and this is what my equation says. Sorry about that. This is the number, and this is what my equation says that the number of factors is. Look at it. You could pause it and go out in the internet and Google. You're gonna see that it's right. This equation, this column, I'm reserving it to show you another equation, which is the two prime equation, another equation I came up with, which is a very simple equation. So the number of factors equation tells you the number of factors, and at the point where it's equal to 2, those are the prime numbers. So here's you got two factors, so 2 is a prime number. Here you got two factors, so 3 is a prime number. Here you got two factors, 5 is a prime number. 2, 7 is a prime number. 2, 11 is a prime number. So it's a pretty simple, straightforward equation, you know? The equation checks for the number of factors. Where it's equal to 2, that's a prime number because that's the definition of a prime number. But here you go. The equation implemented, and the equation is working. You could test it out on the internet, or you could test it out yourself. You could work out the factors yourself, or just Google Google it in the internet. You're gonna see that it works. Okay, and that's it. Thank you. I'm gonna test out some of my other equations using a spreadsheet, so you could see that they all work and they all give you the right value. So keep on going down. Around 42, a little bit of error begins to creep in, but you can still check these values in the internet and you're going to see that they're right and they're solid.